When we talk about AI hallucinations, it's really easy to just write them off as, I don't know, quirky little errors or minor glitches. But what if they're not? What if they're actually a huge red flag, a sign of a deep architectural failure in the very AI systems we're all rushing to deploy? Getting this distinction right is absolutely critical because it's the difference between a small hiccup and a massive, costly liability. I mean, you can't make this stuff up. This might sound like a punchline from a late night show, but it is a real argument a major airline tried to make in court when their AI chatbot went completely rogue. It perfectly captures just how surreal and high stakes this problem of AI making things up has become, and it's our way into a much bigger, much more important conversation. So let's bring this down to earth for a second, because as wild as that last example sounds, these aren't just funny stories to share. We're talking about expensive, brand-damaging failures. We're seeing huge companies get burned by AI that confidently lies, and the cost, well, it's very, very real. Okay, so here's exactly what happened. A passenger needed to fly for his grandmother's funeral. He goes to Air Canada's website, and the chatbot tells him, no problem, just book the full fare flight now, and you can apply for a bereavement discount later. Simple, right? Well, when he tried to do just that, the airline told him the chatbot was completely wrong. That's just not how their policy works. And that is the exact amount a tribunal ordered Air Canada to pay back to that customer. The ruling was crystal clear. It doesn't matter if the information comes from a static web page or a fancy chatbot, the company is still responsible. Yeah, that's a pretty costly lesson in accountability. And believe it or not, it gets even more serious than that. The Australian government paid Deloitte almost $300,000 for a report on their welfare system. The problem? A law professor started reading it and realized it was full of completely fabricated references and totally made-up legal cases. It was obviously generated by an LLM that was just inventing things. This quote from an Australian senator really just puts it in perfect perspective. This wasn't some sophisticated, hard-to-catch error. It was a basic, completely unacceptable mistake. Of course, Deloitte had to reissue the whole report and admit that, yep, Azure OpenAI was used to help write it. Okay, so here's the crucial takeaway. These aren't just isolated incidents. They are symptoms of a really deep architectural flaw. I want you to think of it like this. Imagine you hire a brilliant consultant. I mean, they're an absolute genius in the room. But the second they walk out the door, they forget everything. Every single meeting, you have to start completely from scratch. Well, that's pretty much how most AI agents are operating today. And this gets us to what a hallucination really is. It happens when the AI just doesn't know something, and so it's forced to invent an answer that sounds plausible. But here's the key. The blame isn't really on the model itself. The real problem is the system architecture that creates those knowledge gaps in the first place. An architecture that relies on the model's flawed memory instead of on verified, truthful sources. Now, this is where things get really fascinating, and frankly, a little counterintuitive. There's this failure mode called the partial context trap. You'd think, right, that giving an AI some information has to be better than giving it nothing. Well, it turns out that giving it just part of the story can be way, way more dangerous. And this chart illustrates the problem perfectly. Just look at the left side here. When these models were fed only partial information, they all failed. And they didn't just fail, they failed confidently. They gave answers that sounded totally believable but were completely wrong. Now look at the right. When those exact same models were given the ability to actively go find the full context they needed, their performance shot up to almost perfect. This is that silent, really dangerous trap that's hiding inside so many AI systems right now. And this is exactly why we need a fundamental shift in our thinking. We have to move away from these architectures that just treat AI like a passive box you feed information into. We need to move towards a new model, one that's built from the ground up around active autonomy and a durable, reliable memory. And here is that paradigm shift visualized. On the left, you've got the old, passive way of doing things. A black box pipeline just shoves information at the AI, and the AI has no say in the matter. On the right, you see the active approach from a system called Poor Man's Memory, or PMM. Here, the AI becomes an active player. It navigates a structured, auditable archive, and it decides for itself what information it needs to do its job. And this really gets to the core philosophical difference. The standard way is what we call context stuffing. You just dump a huge, messy pile of information into the prompt and cross your fingers hoping for the best. It's brittle, it's expensive, and it's completely unauditable. The new way is about hydrating memory. You don't stuff, you give the agent structured files and you teach it where to look. Smart structure replaces clumsy search, and a simple tool that we all know, Git, replaces complex infrastructure to provide a perfect auditable memory. So how does this actually work? Well, it's all powered by a 4-tier memory hierarchy. The easiest way to think about it is like a human brain. Tier 1 is your short-term operational memory, what you need right now. Tier 2 is for specific lookups, like remembering a fact. Tier 3 is the deep, long-term archive, everything you've ever learned. And crucially, Tier 4 is a perfect auditable Git history of every single change. That means total recall and total accountability. Of course, a new architecture sounds great on paper, but does it actually work? The proof is in the pudding, right? So let's look at the hard data from over 2,100 evaluated tests that show just how effective this approach really is. This chart tells a really powerful story. On the far left is the standard industry approach, something called RAG. In the middle, you've got PMM. And on the far right is the Oracle. That's a theoretical perfect score, where a human literally hands the AI the exact right information. As you can see, PMM dramatically outperforms that standard baseline and gets incredibly close to that perfect human-assisted score. And this is the headline number. The performance gap between PMM's fully automated system and a perfect human-curated answer is just razor thin. To put that in perspective, other common AI systems often fall short of that perfect score by 25 to 35 points. This new architecture is 5 to 6 times closer to perfect. But honestly, this might be the most important number on the screen, especially if you're worried about risk. Across thousands of tests with the world's best models, the number of times PMM fabricated or just plain made up institutional knowledge? 0. Not once. It trades the risk of a confident wrong answer for honest uncertainty, which is a much, much safer profile for any real-world deployment. And when you look at this detailed breakdown, you can see this isn't a fluke. The base agent with no memory, well, it performs pretty poorly. The Oracle score, on the other hand, is the ideal. That's our goal. And PMM, the automated system, consistently performs at an incredibly high level across all these different test scenarios. The architecture just flat out works. So this brings us all the way back to the fundamental choice. As you bring AI into your organization, you have to ask yourself, are you building an amnesic consultant that starts every single day with a blank slate full of hidden risks and potential liabilities? Or are you building an auditable, reliable teammate with a memory it can actually count on? The architecture you choose today will absolutely determine that answer.